Alrighty, Rue, problem number 6A. All these problems for 6, this is conditional probability, which basically means it's going to limit what we're looking at and give us more accurate probabilities, or more specific probabilities given certain situations. So the first thing you need to know how to do is you got to know how to read what it's actually asking you. Because it's a little strange. It's got the probability like we normally see, the capital P. It's got the parentheses for the event like normal, but it's got this weird line in the middle. Now, what that line means is it means that the event to the right of it, that professionals, that is the condition that we are saying we know to be true. So what we're saying is if we know that we're looking only at professionals, it allows us to only look at these two numbers right here because we don't care about sales and we don't care about laborers. We only care about those professionals. So what's the probability that that a random person chosen is a male, given that they are a professional? Well, we're going to take the number of males, which is 4,190, and divide it by the total number of professionals. So notice that our denominator is professionals, not all the people, but just the professionals, which is 4,190 plus 4,747. So add those two together and figure out that value, and you should get 46.88%. 6B, again, once you figure out what it's asking, it's fairly straightforward. We want to know what's the probability that a person chosen at random is a professional, given that they are a woman, given that they are female. So again, that condition right there essentially lets us eliminate a lot of our numbers. We don't care about the men. Yeah, screw the men. We only care about the women. So the women, again, that total number of women, that is our condition. So that's going to be our denominator. So we're going to get our 4,747 plus 3,213 plus 1,432 for the total women there. And we want to know, of the women, what's the probability that a random person chosen is a professional? So we take that professional numerator, which is 4,747. So add up your denominator, take your numerator, and divide it by that. 47, blah, 3, 2, 1, 3, plus, sorry, I'll do this in the behind the scenes next time, but you should get 50.54%. Okay, 6C, very similar to 6B. Again, the condition that we're given is that we're looking at females only. So again, stick it to the man. Stick it to the men, I guess, this time. But we already found that denominator last time, so save ourselves some work. So now we just want to know, of the women, what's the probability of getting a laborer? Well, there are 1,432 laborers, and divide that again by the total number of women. I'm not going to write all the addition out. We just did it. Same thing as last time. Do that, and you should get, let's see, we got 1432. You should get 15.24%. 15.24% chance that you are a laborer, given you are a woman. Problemo number 6D. What is the probability that a person chosen at random is a female, given that they are in sales? So again, sales is the condition. That's going to be our denominator. So we're going to get the total number of people in sales, 2,588 plus 3,213. And we are going to divide that by the number of women in sales, which is 3,213. Do that. You should get 55.38%. All right, almost done at this one now. 6E. what's the probability of getting a person in sales, given that we are only looking at the dudes. So again, men, that's going to be our denominator. So we're going to get 4,190 plus 2,588 plus 2,951. And we want to take the number of men in sales, because again, we don't care about the women this time, a little gender equality there since we didn't care about the men before. But the number of men in sales is 2,588. So divide the number of men in sales by the total number of men in general, and you should get 26.6%. All right, last one for this problem, 6F. What's the probability of being a male given you are a laborer? So now, again, denominator is just that second condition. We're looking at the number of laborers. So 2,951 plus 1,432. It's going to get you 4,383. But our numerator then should be the number of men, laborers. So 2,951. Calculate that, and you should get 67.32%, and you should be totally solid on conditional probability now.